Welcome to Loops and Loops, your premier source for all things TypeScript. In this dynamic realm of web development, TypeScript stands out as a robust and versatile programming language, known for its strong static typing and scalability. Join us as we delve into the intricacies of TypeScript, exploring its features, benefits, and applications in modern software development. Whether you're a seasoned developer, looking to expand your toolkit, or a newcomer eager to dive into the world of programming, you're in for an enlightening journey. So tighten your loops, brace yourself for an exploration of code elegance, and let's unravel the complexities of TypeScript together. TypeScript is a programming language developed by Microsoft that adds static typing to JavaScript. It's essentially a superset of JavaScript, meaning that any valid JavaScript code is also valid TypeScript code. TypeScript builds on top of JavaScript, providing additional features and tools to help developers write more scalable and maintainable code. One of the key benefits of TypeScript is its ability to catch errors early in the development process. By adding static typing, TypeScript allows developers to define the types of variables, function parameters, and return values in their code. This helps catch type-related errors at compile time before the code is run, reducing the likelihood of bugs and runtime errors. The main features of TypeScript include static typing, interfaces, classes, generics, modules, and more. These features enable developers to write cleaner, more organized code and take advantage of modern programming patterns and practices. TypeScript improves code maintainability and scalability by providing tools for better code organization and structure. With features like interfaces and classes, developers can define reusable components and enforce clear boundaries between different parts of their code base. This makes it easier to understand and maintain large code bases over time. Static typing in TypeScript allows developers to specify the types of variables, function parameters, and return values in their code. This helps catch errors early in the development process and provides better tooling and editor support for code navigation, refactoring, and documentation. Using TypeScript over plain JavaScript offers several benefits, including improved code quality, better tooling support, enhanced developer productivity, and easier collaboration on large projects. TypeScript also helps prevent common JavaScript pitfalls and provides a smoother development experience overall. TypeScript's type inference feature automatically infers the types of variables and expressions based on their usage in the code. This reduces the need for explicit type annotations and makes the code more concise and readable while still providing type safety. The TypeScript compiler is responsible for transforming TypeScript code into JavaScript code that can be executed by a web browser or Node.js runtime. It performs type checking, syntax parsing, and code optimization to ensure that the resulting JavaScript code is efficient and error-free. TypeScript supports object-oriented programming principles such as classes, inheritance, encapsulation, and polymorphism. Developers can use classes and interfaces to define custom data types and leverage features like inheritance and access modifiers to create modular and maintainable code. Interfaces in TypeScript are used to define the structure of objects and provide a way to enforce type constraints on object properties. Classes, on the other hand, are used to define blueprints for creating objects with properties and methods. While interfaces focus on the shape of objects, classes provide implementation details and behavior. Some of the basic types available in TypeScript include number, string, boolean, array, tuple, enum, any, void, and null defined. These types allow developers to specify the data types of variables and function parameters, providing better type safety and code clarity. TypeScript performs type compatibility and type checking to ensure that variables, function parameters, and expressions are used in a type-safe manner. This helps catch errors and prevent type-related bugs during the development process. Union types in TypeScript allow developers to specify that a variable or function parameter can have multiple possible types. This is useful when a value can be of different types in different parts of the code, or when working with APIs that return different types of values based on certain conditions. TypeScript enums are a convenient way to define sets of named constants. They allow developers to assign meaningful names to numeric values and provide type safety by restricting assignments to only valid enum values. Enums make code more readable and maintainable by replacing magic numbers with descriptive names. TypeScript supports asynchronous programming patterns using promises and async await syntax. Promises are used to represent asynchronous operations and handle their results or errors. Async await syntax provides a more concise and readable way to write asynchronous code by allowing developers to write asynchronous code that looks synchronous. This makes it easier to work with asynchronous operations such as fetching data from a server or performing input-output operations. TypeScript coding patterns and best practices include using type annotations for function parameters and return types, using interfaces or types to define custom data shapes, leveraging generics for reusable code, using enums for named constants, and following naming conventions for variables, functions, and classes. Additionally, developers should use strict mode to catch more errors at compile time, avoid using the any type whenever possible, and use type guards to narrow down types when working with union types. TypeScript integrates seamlessly with popular JavaScript frameworks like React and Angular by providing type definitions that enable static type checking and better tooling support. This allows developers to write safer and more maintainable code while leveraging the benefits of these frameworks. Generics in TypeScript allow developers to write reusable code by creating functions, classes, or interfaces that can work with a variety of data types. This enables developers to write flexible and type-safe code while avoiding code duplication. TypeScript handles modules using the ES6 module syntax, allowing developers to organize code into separate files and manage dependencies more efficiently. Module loading is handled by module loaders like Webpack or TypeScript's own module resolution algorithm. Some limitations or drawbacks of using TypeScript include the additional learning curve for developers new to static typing, increased compilation time due to type checking, and potential compatibility issues with existing JavaScript code bases or libraries that lack type definitions. Type guards in TypeScript are conditional statements or functions that narrow down the possible types of a variable within a certain code block. They help developers write more precise and type-safe code when working with union types or type assertions. TypeScript allows developers to perform type assertions or type casting using the as keyword. This allows developers to tell the TypeScript compiler to treat a variable as a specific type, even if TypeScript cannot infer it automatically. Tools and integrated development environment that support TypeScript development include Visual Studio Code, WebStorm, Sublime Text, and Atom. These tools provide features such as syntax highlighting, code completion, error checking, and refactoring support for TypeScript code. Type inference in TypeScript allows the compiler to automatically determine the types of variables based on their usage in the code. This reduces the need for explicit type annotations and makes the code more concise and readable. Common TypeScript configuration options include specifying compiler options in config.json file, setting target ECMAScript versions, enabling strict mode, configuring module resolution, and defining include and exclude paths for compilation. The TypeScript handles null and undefined values by providing strict null checks, which prevent null or undefined values from being assigned to variables unless explicitly allowed. This helps catch potential null-related bugs at compile time. The keyoff operator in TypeScript is used to obtain the keys of an object type as a union of string literal types. This allows developers to create more precise type definitions and perform type-safe operations on object properties. TypeScript supports functional programming concepts such as higher-order functions, function composition, and immutability. This allows developers to write more concise and expressive code while leveraging the benefits of functional programming. Type narrowing in TypeScript refers to the process of narrowing down the possible types of a variable within a certain code block. This can be done using type guards, conditional statements, or switch statements, allowing developers to write more precise and type-safe code. TypeScript handles type widening and narrowing based on how variables are assigned and used in the code. Type widening occurs when TypeScript infers a broader type for a variable than what was explicitly assigned. For example, when a variable is initialized with a specific value, TypeScript may widen its type to include all possible values of that type. Type narrowing, on the other hand, occurs when TypeScript narrows down the type of a variable based on conditional checks or type guards. This helps developers write more precise and type-safe code by reducing the range of possible types for a variable. Common TypeScript linting tools include tslint and ESLint, which can be configured to enforce coding standards and best practices. Developers can customize linting rules to fit their project's requirements, such as enforcing consistent indentation, prohibiting the use of certain language features, or requiring documentation for functions and variables. Conditional types in TypeScript allow developers to create types that depend on other types. This enables developers to create more flexible and reusable type definitions based on runtime conditions or other type parameters. TypeScript supports function overloading and method overloading, allowing developers to define multiple function or method signatures with different parameter types or numbers. This enables developers to write more expressive and type-safe code by providing different ways to call functions or methods. Type inference for array types in TypeScript allows the compiler to automatically determine the type of an array based on its elements. This helps reduce the need for explicit type annotations and makes the code more concise and readable. TypeScript handles private, protected, and public access modifiers to control the visibility of class members. Private members can only be accessed within the class that defines them. Protected members can be accessed within the class and its subclasses, and public members can be accessed from anywhere. Common TypeScript development workflows include setting up a TypeScript project with a tsconfig.json file to configure compiler options, using package managers like npm or yarn to manage dependencies, and integrating with build tools like Webpack or Parcel for bundling and optimization. Namespace imports in TypeScript allow developers to import multiple exports from a module using a single import statement, while wildcard imports allow importing all exports from a module using an asterisk. These import styles help improve code readability and maintainability by reducing the number of import statements. TypeScript handles type assertions using the AES keyword, which tells the compiler to treat a variable as a specific type. Non-null assertions, denoted by the exclamation mark operator, assert that a variable is not null or undefined. These features help developers write more flexible and type-safe code. Common TypeScript utility types like partial, pick, and record provide shortcuts for creating new types based on existing ones. Partial allows creating a type with all properties optional. Pick allows selecting specific properties from a type, and record allows creating a type with specified keys and value types. Function types and callable types in TypeScript allow developers to define types that represent functions or callable objects. This enables developers to specify the signature of functions or methods more precisely and enforce type safety when passing functions as arguments or returning them from other functions. TypeScript handles type narrowing with the instance of operator by narrowing down the type of a variable to a specific class or constructor function. This allows developers to perform type-safe operations on objects based on their class membership. Common TypeScript deployment strategies include compiling TypeScript code to JavaScript using the TSC compiler, bundling JavaScript files with tools like Webpack or Parcel, and deploying the bundled code to a web server or cloud platform. Index signatures in TypeScript allow developers to define types that represent objects with dynamic property names. This enables developers to work with objects that have a varying set of properties at runtime, providing more flexibility and expressiveness in type definitions. TypeScript employs type guards for discriminated unions to narrow down the types of objects within union types based on their properties. This helps developers write more precise and type-safe code by enabling TypeScript to infer the specific type of an object based on its discriminant property, by checking for the existence or value of a discriminant property. Developers can refine the type of an object within a union, making it easier to work with different variants of the same type. Type inference for object literals in TypeScript allows the compiler to automatically determine the types of properties in object literals based on their assigned values. This feature helps reduce the need for explicit type annotations and makes code more concise and readable. TypeScript handles type narrowing with type predicates by allowing developers to define custom functions that assert the type of a variable based on certain conditions. These type predicates, typically written as functions returning a Boolean value, help TypeScript narrow down the type of a variable within conditional statements or type guards. Common TypeScript development tools for browser-based applications include Webpack for bundling and optimizing code, Babel for transpiling TypeScript code to JavaScript, and Jest for testing. These tools help streamline the development process and improve the quality and performance of web applications. Intersection types in TypeScript allow developers to combine multiple types into a single type that contains all the properties and methods of each constituent type. This enables developers to create more flexible and reusable type definitions by combining different interfaces or object types. TypeScript handles type guards for null and undefined values by allowing developers to use type of checks, truthy falsy checks, or optional chaining to assert the presence or absence of these values. This helps prevent runtime errors caused by accessing properties or methods on null or undefined values. Common TypeScript development patterns for Node.js applications include using TypeScript with Express.js for building web servers, integrating with popular databases like MongoDB or PostgreSQL, and leveraging NPM packages for implementing various functionalities. These patterns help developers write scalable and maintainable backend code with TypeScript. Type inference for tuple types in TypeScript allows the compiler to automatically determine the types of elements in tuple literals based on their positions. This feature helps reduce the need for explicit type annotations and makes code more concise and readable. TypeScript handles type narrowing with type assertions by allowing developers to explicitly tell the compiler the type of a variable using the as keyword or angle bracket syntax. This helps developers assert the type of a variable in situations where TypeScript cannot infer it automatically, improving type safety and code readability. Common TypeScript development patterns for React applications include using TypeScript with JSX for building user interfaces, managing application state with libraries like Redux or MobX, and integrating with tools like Webpack or Create React App for bundling and deployment. These patterns help developers write type-safe and maintainable front-end code with TypeScript and React. Conditional types and inference in TypeScript allow developers to define types that depend on other types or values. This enables developers to create more flexible and reusable type definitions based on runtime conditions or other type parameters, improving the expressiveness and type safety of TypeScript code. TypeScript handles type narrowing with control flow analysis by tracking the flow of variables through conditional statements and narrowing down their types accordingly. This helps TypeScript infer more precise types for variables within conditional branches, improving type safety and code readability. Common TypeScript development patterns for Angular applications include using TypeScript with Angular CLI for building and scaffolding projects, implementing services and components with dependency injection, and leveraging Oryx.js for handling asynchronous operations. These patterns help developers write scalable and maintainable front-end code with TypeScript and Angular. Type inference for generic types in TypeScript allows the compiler to automatically determine the type of a generic function or class based on its usage. This helps reduce the need for explicit type annotations when working with generic types, making code more concise and readable while still maintaining type safety. TypeScript handles type narrowing with type predicates by allowing developers to define custom functions called type predicates that assert the type of a variable based on certain conditions. These type predicates typically return a Boolean value and are used within conditional statements or type guards to narrow down the type of a variable. By checking specific conditions, TypeScript can infer a more precise type for the variable, improving type safety and code readability. Common TypeScript development patterns for Vue.js. Applications include using TypeScript with Vue CLI for project scaffolding, managing application state with Vuex for state management, and integrating with Vue Router for routing functionality. Developers often leverage TypeScript's strong typing capabilities to ensure type safety throughout their Vue.js applications, improving code maintainability and scalability. Type inference for union types in TypeScript allows the compiler to automatically determine the common type shared by values within a union. This means that if a variable has a union type, TypeScript can infer the appropriate type based on the operations performed on that variable. This feature helps reduce the need for explicit type annotations and makes code more concise and readable. TypeScript handles type narrowing with type guards by allowing developers to use instance of checks, type of checks, or user-defined type guards to refine the type of a variable within conditional statements. This helps TypeScript infer more precise types for variables, improving type safety and enabling developers to write more robust code. Common TypeScript development patterns for Express.js applications include using TypeScript with Express Generator for project setup, implementing middleware for request processing, and integrating with databases like MongoDB or PostgreSQL for data persistence. TypeScript static typing helps developers catch errors early and write more maintainable code in Express.js applications. Type inference for function return types in TypeScript allows the compiler to automatically determine the return type of a function based on its implementation. This feature helps reduce the need for explicit return type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with instance of guards by allowing developers to use the instance of operator to check the type of an object at runtime. This helps refine the type of a variable within conditional statements, enabling TypeScript to infer more precise types and improve type safety. Common TypeScript development patterns for Nest.js applications include using TypeScript with Nest CLI for project scaffolding, organizing code into modules and controllers for better structure, and leveraging dependency injection for managing dependencies. TypeScript's strong typing capabilities help developers build scalable and maintainable backend code with Nest.js. Type inference for function parameters in TypeScript allows the compiler to automatically determine the types of function parameters based on their usage within the function body. This feature helps reduce the need for explicit parameter type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with literal types by allowing developers to narrow down the type of a variable based on its literal value. This means that if a variable has a literal type, TypeScript can infer the appropriate type based on the assigned value, improving type safety and enabling more precise type inference. Common TypeScript development patterns for React Native applications include using TypeScript with React Native CLI for project setup, managing application state with libraries like Redux or MobX, and integrating with native modules for platform-specific functionalities. TypeScript static typing helps developers write more reliable and maintainable code in React Native applications. Type inference for object properties in TypeScript allows the compiler to automatically determine the types of object properties based on their assigned values. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with the in operator by allowing developers to use the in operator to check if a property exists on an object at runtime. This helps refine the type of a variable within conditional statements, enabling TypeScript to infer more precise types and improve type safety. Common TypeScript development patterns for Electron applications include using TypeScript with Electron Forge for project scaffolding, managing application windows and menus with Electron APIs, and integrating with web technologies like HTML, CSS, and JavaScript for building user interfaces. TypeScript static typing helps developers catch errors early and write more maintainable code in Electron applications. Type inference for function expressions in TypeScript allows the compiler to automatically determine the types of function parameters and return types based on their usage within the function expression. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with type intersections by allowing developers to combine multiple types into a single type using the intersection operator. When TypeScript encounters a value that has a type that is an intersection of multiple types, it narrows down the type of that value by checking if it satisfies all the individual types in the intersection. This helps TypeScript infer more precise types for variables and enables developers to write more robust code. Common TypeScript development patterns for GraphQL applications include defining GraphQL schemas using TypeScript interfaces or classes, implementing resolvers to fetch and manipulate data, and using Apollo client or Relay for client-side data fetching and catching. TypeScript static typing helps catch errors early and ensure type safety throughout the development process of GraphQL applications. Type inference for class properties in TypeScript allows the compiler to automatically determine the types of class properties based on their assigned values or initializers. This feature helps reduce the need for explicit type and annotations in classes and makes code more concise and readable while still ensuring type safety. TypeScript handles type narrowing with type unions by allowing developers to combine multiple types into a single type using the union operator. When TypeScript encounters a value that has a type that is a union of multiple types, it narrows down the type of that value by checking if it satisfies at least one of the individual types in the union. This helps TypeScript infer more precise types for variables and enables developers to write more flexible code. Common TypeScript development patterns for RESTful API applications include defining RESTful routes using Express.js or Nest.js, implementing controllers to handle HTTP requests and responses, and using middleware for request processing and authentication. TypeScript's strong typing capabilities help catch errors early and ensure type safety in RESTful API development. Type inference for function arguments in TypeScript allows the compiler to automatically determine the types of function parameters based on their usage within the function body. This feature helps reduce the need for explicit parameter type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with type assertions by allowing developers to assert the type of a variable to a more specific type using the A's keyword or angle bracket syntax. This helps refine the type of a variable within conditional statements, enabling TypeScript to infer more precise types and improve type safety. Common TypeScript development patterns for WebSocket applications include defining WebSocket endpoints using libraries like Socket.io, handling WebSocket events and messages with event listeners, and integrating with real-time databases or message brokers for data synchronization. TypeScript static typing helps catch errors early and ensure type safety in WebSocket application development. type inference for object literals in TypeScript allows the compiler to automatically determine the types of object properties based on their assigned values in object literals. This feature helps reduce the need for explicit type annotations and makes code more concise and readable while still ensuring type safety. TypeScript handles type narrowing with type guards by allowing developers to define custom functions called type guards that check the type of a variable at runtime. This helps refine the type of a variable within conditional statements, enabling TypeScript to infer more precise types and improve type safety. Common TypeScript development patterns for real-time chat applications include defining chat rooms and message models using TypeScript interfaces or classes, implementing WebSocket endpoints for real-time communication, and using libraries like Socket.io, or GraphQL subscriptions for data synchronization. TypeScript's strong typing capabilities help catch errors early and ensure type safety in real-time chat application development. Type inference for array literals in TypeScript. It allows the compiler to automatically determine the types of array elements based on their assigned values in array literals. This feature helps reduce the need for explicit type annotations and makes code more concise and readable while still ensuring type safety. TypeScript handles type narrowing with discriminated unions by allowing developers to define discriminant properties in union types, which serve as tags to differentiate between the possible types in the union. When TypeScript encounters a value with a discriminated union type, it narrows down the type of that value based on the discriminant property, enabling more precise type inference and improved type safety. Common TypeScript development patterns for social media applications include defining user profiles and post models using TypeScript interfaces or classes, implementing create, read, update, delete operations for managing user-generated content, and integrating with authentication and authorization systems for user authentication and access control. TypeScript static typing helps catch errors early and ensure type safety in social media application development. Type inference for destructured objects in TypeScript allows the compiler to automatically determine the types of object properties based on their usage within destructured assignments. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with conditional types by allowing developers to define conditional expressions that depend on the types of variables. Conditional types use the extends keyword to specify type relationships, enabling TypeScript to infer more precise types based on conditions. For example, developers can use conditional types to conditionally select or map types based on the properties or characteristics of other types, improving type safety and code readability. Common TypeScript development patterns for e-commerce applications include defining product models and inventory management systems using TypeScript interfaces or classes, implementing shopping cart functionality and checkout processes, and integrating with payment gateways and shipping services. TypeScript static typing helps catch errors early and ensure type safety in e-commerce application development. Type inference for REST parameters in TypeScript allows the compiler to automatically determine the types of REST parameters in function declarations based on their usage within the function body. REST parameters are denoted by the spread operator, followed by a parameter name, and TypeScript infers the type of the REST parameter as an array containing the specified element type. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with nullable types by allowing developers to define nullable types using the union type operator with null or undefined. When TypeScript encounters a value with a nullable type, it narrows down the type of that value by checking if it is not null or undefined, enabling more precise type inference and improved type safety. Common TypeScript development patterns for content management systems Include defining content models and structured data schemas using TypeScript interfaces or classes, implementing create, read, update, delete operations for managing content, and integrating with databases or content repositories for data storage and retrieval. TypeScript static typing helps catch errors early and ensure type safety in CMS application development. Type inference for spread elements in TypeScript allows the compiler to automatically determine the types of array elements or object properties based on their usage within spread expressions. Spread elements are denoted by the spread operator followed by an array or object, and TypeScript infers the types of the spread elements based on the types of the elements being spread. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with type predicates by allowing developers to define custom functions called type predicates that check the type of a variable at runtime. Type predicates use the is keyword to specify a type condition. And when TypeScript encounters a value that satisfies the type predicate, it narrows down the type of that value, enabling more precise type inference and improved type safety. Common TypeScript development patterns for web scraping applications include defining data models and scraping rules using TypeScript interfaces or classes, implementing scraping logic to extract data from web pages, and using libraries like Puppeteer or Cheerio for web scraping. TypeScript static typing helps catch errors early and ensure type safety in web scraping application development. Type inference for array spread operations. In TypeScript allows the compiler to automatically determine the types of array elements based on their usage within array spread expressions. Array spread operations are denoted by the spread operator followed by an array, and TypeScript infers the types of the array elements based on the types of the elements being spread. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. TypeScript handles type narrowing with type assertions by allowing developers to assert the type of a variable to a more specific type using the as keyword or angle bracket syntax. This helps refine the type of a variable within conditional statements, enabling TypeScript to infer more precise types and improve type safety. Common TypeScript development patterns for machine learning applications include defining data models and training pipelines, using TypeScript interfaces or classes, implementing machine learning algorithms and data pre-processing techniques. Type inference for template literals in TypeScript allows the compiler to automatically determine the types of template literal expressions based on their usage within template literal strings. TypeScript infers the type of a template literal expression as a string concatenation of its constituent parts, including string literals and interpolated values. This feature helps reduce the need for explicit type annotations and makes code more concise and readable, while still ensuring type safety. As we conclude today's exploration of TypeScript, we trust you have gained valuable insights into the capabilities and potential of this powerful language. Remember to like, share, and subscribe to Loops and Loops for more in-depth content on TypeScript and other cutting-edge technologies. Let's continue to loop in new knowledge, refine our coding skills, and build a future where innovation thrives. Until next time, keep those loops tight, keep coding, and keep exploring the ever-evolving world of web development. Thank you for joining us on this enriching journey.